For number 8, we have a system that is composed of identical components. The probability that each component will fail is given right here. Would it be unusual to observe one component fail? We usually make our cutoff for unusual around 5%. So since this is higher than 5%, no, it's not unusual to observe one component fail. Would it be unusual to observe two components fail? Notice that the components fail independently. So the chances that the first one would fail is given to us. And since they're independent, the chance of the second one failing is the same, and we just multiply their probabilities together. So the chances they would both fail is right there, found by multiplying the chances of each failing. This is below 5%, so yes, it would be unusual to observe them both failing. And if this is the chance of them failing, the next part asks what's the probability that it will succeed, so that it's not going to fail. So if it fails this percentage of the time, the rest of the time it succeeds. So do 1 minus that probability. And here's the probability that it will succeed. And so how many components will be needed in the structure so the probability the system will succeed is greater than 0.9999? So if we want our success to be greater than 0.9999, it means our fail needs to be less than 0.0001. So 3 zeros and a 1. Our fail needs to be less than that. So just like we did in the previous part, the chances of one component failing is there. And to see if there's two components, our probability that they both fail is given. With 3 components, multiply by the chance of failure again. With 4 components, we're getting close, but we need to be smaller than 3 zeros and a 1. So let's see with our 5th component. Now this probability of failure is less than what we need. So we would need 5 components to have a chance of success greater than 0.9999. For number 9, we're given information about the percentage of people in this age group who operated heavy machinery while under the influence of alcohol. And we are going to select 3 of these people at random. The first part is what's the probability that at least one has not operated heavy machinery under the influence. So first notice up here in red the 4 possible breakdowns. If you select 3 people, you could get either one of these 4 options. Either 0 operated under the influence, which means 3 did not. Maybe 1 person operated while 2 did not. Or 2 operated, 1 did not. Or all 3 of those randomly selected people did operate, so 0 did not. And the problem's asking the chances that at least one has not operated. So the probability that someone has not operated, at least one has not operated, would be either one of these first 3 conditions. So either at least one could be 1 person not operating, 2 not operating, or all 3 not operating. So one option is to figure out each of these probabilities individually. So 3 different sections, and then add your results together. But the quicker way to do the problem is to say, well, the only thing left out of the at least one not operating is our last option here. So let's figure out the probability that all 3 operated under the influence. So let's calculate all 3 operating. Well, each person has this probability of operating. The problem said each person has that probability of operating under the influence. And these are independent events because we're randomly selecting people. So to find the probability that all 3 operated, we'd multiply that together for each of them. And here's the chances that all 3 operated and 0 did not. So if this percentage of the time we're in option number 4, that means the rest of the time one of these 3 options is happening. So take 1 minus that percentage, and here's the percentage of time that it's one of these 3 options where at least one did not operate. All right, part B is another at least one problem. The probability that at least one has operated heavy machinery under the influence. So now we're looking at these bottom 3 options. Either one of them operated, 2 of them, or 3 of them operated. So again, you could figure out all 3 of these separately and add them together, but the faster way is to look at the one option left out, which is 0 operating under the influence and 3 not operating.
So what's the chances that someone does not operate under the influence of alcohol? It's 64% chance, because we have a 36% chance they do operate. That means a 64% chance they don't operate the heavy machinery under the influence. So again, independent events, the chances that all three of them did not operate, you would multiply 6.64 together 3 times. And here's the chances that we land in this first group: 3 not operating and 0 operating. Well, then the chances that we're in either one of these bottom 3 would be 1 minus that result. So around 73% of the time we have one of these bottom 3 results where at least one, either 1, 2, or 3 of our selected people operated under the influence.